Okay, so we left off with 7.5. We're just going to do a few more examples in 7.5, tying in stuff that we've done earlier in the unit. So you may notice we have a piecewise function here. And obviously you want to solve the differential equation. By the way, since we have an exam next week, what could this differential equation represent? Mass on a spring. What kind of motion?
Simple?
No.
No, dense when you have. No, dense when you have gradients.
Why don't we look it up?
There's no middle term, so there's no damping at all.
Force undamped.
And it's forced because, yeah, we have this external force applied, which looks like we have this driving force cosine 4t applied for a short time, but then after that, it turns off. Okay, so that's what we have going on here.
So it's force that harmonic.
Yep. So if we take the Laplace transform of the whole equation, why is that funny? What did I say? Like holy equation? Oh, I see. Okay. Okay. So we start off the same way we did yesterday. We take the Laplace transform of the second derivative. What is that? S squared.
Oh, X.
Big X.
Because it's X.
Yeah, just use the whatever variable we have.
S
Minus S times x of 0 minus no s's, but now we have one derivative of 0 plus 16 times capital X minus 16 x of 0. Oh,
Wait, what?
forgot something.
No?
What did I?
X? No, you don't. The capitals. No, you don't.
Yeah,
You just
so
16 XS.
Oh no, we're good.
See if there's no X.
Yep. And then on the right-hand side, the transform of cosine is s over s squared plus 16. Yes?
If on the test, instead of like using S, I use T,
You could immediately.
would I get marked off for that?
I don't know why you could.
It depends on whether your letters are capitalized or uncapitalized.
Oh, but if I get the case right.
Yeah,
How can we use like all those characters
we're going to. We're going to eventually. Right now, we're just going to work on just... oh, wait, where am I? That's why I was messing this up. I'm not looking at the right...
We've been doing this wrong the entire time.
I combined this with another question. Okay, hold on 1 minute. You see how I swapped this? Okay, let's rewrite this. That's my mistake.
In terms of you,
So am I.
But you don't have to look back at your notes.
Let's make some changes.
Did you skip the step of piecewise?
Yeah. I was looking, because I had a different example. I had a cosine in there, and I was looking there. Anyway, so we still have the Laplace transform of f of t. So yes, over here we're going to try to write this in the condensed notation that we've been using in 7.3, I think. So let's write that out. What will f of t be if I use that unit step function? Yeah. Mm-hmm. Good. Bless you. Okay. And now if I want to take the transform of this function, the first part is fine. That's the s over s squared plus 16. And now here, it looks like we want to use the second translation theorem. It's just a phone call.
She's not used to the new phone.
No, it's not like a beat.
If we're going to use the second translation theorem, we need something else, don't we? We need this to be t minus pi. Is that okay if I just put it in there? Yeah, you're right.
Because it's just changing one.
Yeah, because if you put in this, which really becomes 4 pi, all you're doing is shifting it a couple periods, and it's not going to make a difference. Okay, so we have s over s squared plus 16, and now what is the transform of the second part of the step function here? So minus e to the negative pi s, and then s over s squared plus 16. Okay, so sorry about that. We have the left-hand side right here, and then the right-hand side here. So that's where we're currently at. Now we proceed as usual. Factor out capital X. And what's left? S squared plus 16. Let's see, let's plug in some values. X of 0 is 0. X prime was 1. So then on the right-hand side, I'm just going to have 1 plus s over s squared plus 16 minus e to the minus pi s, s over s squared plus 16.
Are you going to simplify that?
What's that?
Are you going to simplify that?
Yes. So now we have 1 over s squared plus 16 plus,
Wait.
I'm dividing by the,
Oh.
right? S over s squared plus 16 squared minus e to the minus pi s, s over s squared plus 16 squared. Okay? So then little x of t will be what? Inverse, right? So what's the inverse of 1 over s squared plus 16? Okay. Plus, and now this is going to get a little shaky because we're going to skip a lot of the hard work and just rely on the table in the book to do this one. I don't know if you have it with you and you want to look at it. I think I may let you use a table of Laplace transforms for this exam. I might print one out for you guys. And that might be the extent of what you get. Does anybody have the book with them, or should I just tell you what it is?
Oh,
Wait, what would you do, guys?
A table of Laplace transforms.
Of all the Laplace transforms?
I don't remember. I don't think it's that one.
Oh, it sounds like front cover.
Mm-hmm.
Yeah, it's
No. It would be like,
Would it be like the easy ones too?
what's Laplace transform?
Maybe.
Would it be
Like the table, basically what's in the book.
Like the derivation of the itself. I haven't used one in the book.
Number 22.
What does it say?
It says 2ks over s squared plus k squared.
So then if we go back,
It's t sine kt.
so then that's good. So then we'd have to do t sine 4t, but we need to adjust something. What was it? 2k, right? In the numerator?
2ks in the numerator.
So we need a 1 over 8 here, right? Does that make sense? And now here, when we do the transform of the second part here, using the inverse of the second translation theorem, it's going to be the same thing, but all these inputs get replaced with what? T t minus pi. So now we're going to have minus 1/8 times t minus pi sine of 4 times t minus pi. And then we have to apply the unit step function at t minus pi. Okay, so this would be the solution to the equation. And that's where we were going to stop yesterday. Okay. I have one more example for you guys to try, and then something I want to show you, and then we'll be done. Are there any questions on this? Okay. Let's set this one up, and then you guys take a few minutes to work through this. So we have y double prime plus 2y prime plus y equals f of t, and here's your picture for f of t. Okay, so take a few minutes. This one will be a little bit more involved, but same concept.
You can't use it. That's the actual.
Sorry. When in doubt, assume there's 0, I guess. The test will be much more
All
clear.
answers are 0. The answer is wrong.
Charlie, what are you doing?
I thought it was a pack a day. So I took the liberty of
You know I've done worse.
maximizing the time. Just
I've
trying to
done
build
worse.
these concepts.
No. We practiced. Why? Oh, no. We have a game today and 2 tomorrow.
Must be a boring day.
It's not boring, no. It's just it's a long day. Like the whole Saturday shot, basically. Oh, you're at
One is what?
minus 2 plus yeah.
Yeah, almost there.
No.
Just,
And if it were like switched,
yeah, I got
like
it.
forward over, it's all based on integration anyway. So
Whatever. And then we
How do you know what the values are? Like if they're 0 or 1 on the graph?
That's F of T.
Because normally you're given like starting positions. Oh, I didn't see those. Yeah.
Oh, thanks.
It is something. It's fun.
It's not even worth it.
Nice.
Yeah.
Yeah, I did. Nice.
If you want to check something, you're not sure where to go, ask.
I'm lost.
Convolution. Are we gonna see a whole lot of like convolution stuff on the test?
Please no.
I feel like no.
Yeah.
Please no.
What's that?
Are we gonna see a whole lot of convolution on the test?
We'll see a little.
Hey guys, what's the
Is this the one where you keep?
What?
I like it as this is the class don't keep.
Ah.
It's the
No, the second is where you keep
I
it.
got you.
First is where you switch.
Minus 2 e to the negative 2.
Unit step function is the.
So this is right.
Yes.
From as-
So what do you just do?
from as-
So why is it? Oh, I see. I see.
You're gonna leave them. Yeah. It won't matter. In the end, you're gonna have to separate a fraction.
Yeah, I did. But
It's your homework board.
he was asking for like this
You all
week.
can see my homework. I have it now.
So, like, I could hold it was there.
Actually, I will gladly read your homework, so that way I don't spend 20 minutes during class.
Did you take pictures of it?
Yes.
7-1, 7.
It's all out of order if you're wanting to.
I'm here.
So it won't be helpful.
This transform 1 over x equals 1 squared.
Yes.
The original one is 10 to the
Like if I do, I'm gonna send it.
Where's 7-4?
I think I did that here. No, I did 7.5 part of it.
Oh, we have it all together, I'll take
Yeah, we'll send it to you.
No, I need my notes. My notes are the same.
Like,
How'd you do?
It's all 1779.
I'm in the Laplace
Okay.
whatever.
I don't
So
know.
that becomes, the original one is t to
Wow.
the e to the negative t.
Well, I thought so.
E to the negative t, and then it's shifted over, then instead of t, it would be t minus 1. And then here it would be.
Started singing that. Did I start singing that?
This is a long
Did you say
set.
that?
Yeah, I did.
Pretty much added
I think the shadow chapter
I
is
feel like that.
Well, I mean, it is right.
Yeah, I know that.
Yeah, we're being tested.
Yeah, like,
Like,
well, I mean, we're gonna get to considering most of the finals, so do you think now it's
And now you want to take the transform instead. So you have to
and
write
it's not everything.
the
No,
like,
functions
I'll go
ones with you, like the unit step
One.
and then do the
This just
transform
means
of
that
that.
it's just
What? I'm so
so
worried about
Wait, what's the separate?
Yeah.
It won't matter because they're all going to be the same.
Isn't it minus?
And in order to do the inversion, you have to use partial
Oh,
fractions
no, that's
of 1 over s. So whether you put together or
No, like
not.
I Wikipedia'd like the Kirchhoff
Wait, so
ones,
when you do
so,
the
like,
partial
before the last
fractions, you just use like the
like,
over?
Yeah, and then you basically ignore the.
I hate it because he does
And then just add it at the end.
try to assess what we know personally instead of both into the test. I know, like the open wire thing, that was
So far, so good.
I hate when
Oh, wait.
everything.
Like,
That's because it's at 2
he's not
that we
gonna
should
teach it to
together.
test us on what he taught us. He's gonna teach it to throw like extra reaction marks. Like I barely understood it.
Like,
Yeah.
oh, it's simple.
It was not really much.
This is pretty much except what the output is, which tells you what function you need. So if currently our function is worth y equals 1, and we want it to turn into y equals
It's
negative
not
1.
cool, though. Definitely not.
Well, that's not there's no funny key cuts. Probably
So
also
it's
just,
It
He
is
is
okay.
like-
It could be u of minus.
Mr. Beast
It
is
was on
couch.
there one day. I was helping.
Yes. But where did that shit happen?
If it's
Oh,
not
no.
different, you
And
And then you have
You
one
asked about
more.
AC classes.
Oh, you didn't
God.
have it there. at the very end. It goes up to 3.
How do you do
No, he's still there.
Oh, okay, so then it's plus.
Nah, still not.
Yeah, you really didn't hear
Plus.
the line.
Can you do
Was A, B, and then it would have been like,
Yeah.
So basically, you do partial fractions
and
for
there's
this.
Xavier
Can I just loop it
But
back?
then
and then there's Billy, who
No,
took
you
the
just treat it
algebra.
all as one process.
Yeah,
Because this is going to change.
Don't look at it. But apparently,
Like,
if it's like
Yeah.
negative.
that'll just.
He did okay last time. I think he got
So what's going to happen is at the end,
He's gonna-
you're going to multiply your decomposition.
but no. Actually,
Actually,
I would
Right,
actually gonna
treat
make
this
this
as like e to the minus times 1 over s over
It's like,
Nah.
I gave it to you right now. It's just scared.
It's really not that hard of a
So like if you put it all together as one fraction, then you do the decomposition.
Well, we're gonna work
These
these.
three
He's gonna give us
terms multiplied.
Yeah. Like 8
We just looked at it to scare us.
Is it plus u 2 minus 3?
Yes.
Probably wrong.
Where did your answer start?
Yeah, it's
Like, who does that?
Yeah, I think
Because that's just.
That's all. Okay.
Oh my god.
that's partial fraction.
Done.
I've seen one. It's
There's the movie that like
In the
really
future,
tries to
it was
get
actually
on.
Yeah.
your entire platform.
Yeah.
That's a funny song.
Okay, so here's what the solution should look like.
Well,
Or I'll start working through it. If you're still working, go for it.
yeah, that's so funny.
It's the same thing
What?
Laplace transform of second derivative is s squared y of s minus s y of 0 minus y prime of 0 plus 2s capital Y minus 2 y of 0, and then we have plus y of s, and then on the right hand side,
I don't know why, but I just know. The other part.
on the right hand side, we're going to take the Laplace transform of f of t, which if you wrote correctly, should be written as u of t minus 1 minus 2 u of t minus 2 plus u of t minus 3. So that's what we're working with on the right. And when you take transform of each one of those, you just get e to the minus s over s plus 2e to the minus 2s over s plus e to the minus 3s over s. Since the,
How much do you care about this?
so the initial conditions are both 0, so this term goes away, that term goes away, this term goes away, and now we're left with y of s times the quantity s plus 1 squared. Actually, and it doesn't matter whether you keep it separate or if you... Bless you. I've never heard, oh my god, after a sneeze.
Yeah, I can't do.
How rude. Okay. So then we divide by s plus 1. Bless you.
Oh my god. Not that one.
Please.
Sneeze.
Oops. I messed something up. This was minus here. Thank you. Because we subtracted 2 of u. So we have minus 2. So here's what we have. And now from here to do the inverse of this whole thing. So if we want to do the inverse transform of the equation, then that will give us y of t. But we have this fraction that's present in all three terms that we have to worry about. So what I would recommend doing is treat the numerators as, or basically just ignore them for the time being, to figure out what the decomposition is for 1 over s plus 1, 1 over s times s plus 1 squared. Once you have the decomposition for this, then these numerators will essentially just multiply that decomposition. So rather than make things complicated and have these weird exponentials as part of the system, just find 1 for each one and then multiply it through. So then decomposition for this would be a over s plus b over s plus 1 plus c over s plus 1 squared. So then we get 1 equals a s plus 1 squared plus bs s plus 1 plus cs. So that's a s squared plus 2as plus a plus bs squared plus bs plus cs. So now what's our system? A plus b has to be 0 because there's no s squareds. 2a plus b plus c, 0. And then our constant, 1, has to come from a. So if a is 1, b is negative 1, and then c would have to be, whoops, also negative 1. Okay. So now, depending on how we want to proceed from here, you could just write all three terms out separately, or you could group them all together. It really doesn't make a difference. I think it might be easier to kind of separate them so that then you can plug in all the unit step function stuff. So y of t is now going to be, so remember what we had here, e to the minus s, right? So we'll have e to the minus s times, and then I'm going to be very lazy with my work, but remember this is 1 over s, negative 1 over s plus 1, and negative 1 over s plus 1 squared. And now the transform of 1 over s, well actually, I should just write them in. Don't worry about it. I'm going to write it in anyway. So that's the first term, minus 2 e to the minus 2s. Same thing.
Oh, I get it.
Oh, actually, I do.
You just get it?
That was awesome.
Did you get it?
That'd be funny if I taught like Mr. Gonzalez had. Oh, that's too bad.
That's what I'm laughing at.
That's a little bit nicer.
That's probably what I Screw you.
Okay, so after you get the decomposition, you plug everything in. Here's what we're left with. Now we can use the inverse transform. So this is still technically y of s up here. That's my bad. And then when we do the inverse transform, we get y of t equals what? So basically, this means there's a second translation theorem shift. We have to apply this to every transform in here at negative 1. So what's the transform of 1 over s, or the inverse transform? 1, so that's fine. Minus the inverse transform of this is e to the negative t, but we're going to replace t with t minus 1 due to the second translation theorem. Minus, this would be t e to the negative t, right? So t minus 1 e to the negative t minus 1, and then this is all times u of t minus 1. So that's the first part of the solution.
And so on.
The second part, and so on. The second part of the solution is similar. So now we'd have minus 2 times the quantity.
You wouldn't give us something like this on the test.
You should plan on seeing something similar to this on the test.
Can we just
Because
leave
this
it like
assesses not only do you understand using Laplace transforms for differential equations, but whether or not you can apply the inverse and all that of the second translation theorem.
No, but like as complicated with like the.
Well, this isn't horribly complicated. I mean, it's a lot of work.
No, it is. Like if we didn't have you to guide us through it, it is.
Well, that's why you have time to practice.
Oh.
It's not like the test is in a minute.
Like, will we have something where we have to like distribute along the partial fractions like we did? Like,
Yes, probably.
Can we just leave the answer like that?
Minus 2 blank? No, we're not going to do that.
No, I meant if we just leave finding answers.
Once we
Leave it
finish,
like
I'll
that.
just leave with all the parentheses.
Oh, yeah,
Mm.
absolutely.
Okay, good.
Yeah, I was like, no way to check.
So do you guys see what's going to happen here? All your inputs get replaced with t minus 2s for the second part,
And so on.
and then the last part will be, what was it, just plus 1?
this is horribly.
So plus just 1, and then 1 minus e to the negative t minus 3 minus quantity t minus 3 e to the negative t minus 3. And I'm out of space. Oh no.
Do I just write a bunch of
This is all multiplied by u of t minus 3. Okay? So first quantity times u of t minus 1. Second quantity is identical. Just replace your inputs with the new shift, and then same with the third one. Okay? One time I did not say shift, and it came out wrong.
Yeah, I noticed. It was actually a couple.
Really? Okay. So, one last thing.
Like you're bored.
Kept saying
BS. Yeah. Useful in solving other types of equations.
This is gonna be long.
No.
Like 3 lines.
In which an unknown function is in the integrand. So this is just, honestly, this is just something that's useful occasionally, and it's a very specific type of, yeah. So I mean, if we're looking at f of t equals, let's say, g of t plus some integral from 0 to t, and then we have f of tau, and we have h of t minus tau d tau. So here's where we have the convolution theorem set up. But the point is, if we want to find f of t, because here we have f of t, but it's also defined in terms of this integral. This is what I mean. This is the specific case that we're talking about, where we can use the convolution theorem to figure it out. And the same goes as before. We want to take the Laplace transform of everything, and then that makes life really easy. So for example, if we have f of t equals 3t squared minus e to the negative t minus the integral from 0 to t of f of tau e to the t minus tau d tau. And our goal is to solve for f of t. Okay. Honestly, we would be done, except for the fact that we have f as the part of the integrand here. So that's why we have to take the Laplace transform of everything. So if we take the Laplace transform of f of t, now we have 3 times the Laplace transform of t squared minus the Laplace transform of e to the minus t minus, and then here's where we're using the convolution theorem. This is the convolution of what functions? F and e to the t, right? So this is the convolution of f and e to the t, and when we take the transform of that, that's just the Laplace transform of f, and then multiplied, you guys remember that theorem? Well, I would recommend reviewing it then. Multiplied with e to the t. Okay? So then now we get capital F of s equals 3 times the quantity, 2 over s cubed, minus 1 over s plus 1 minus capital F times 1 over s minus 1. So it's kind of like solving the differential equation in the sense that we first have to take the Laplace transform to find capital F of s. So if we factor it out, we're left with 1 minus 1 over s minus 1, or plus, sorry. Yeah, I'm factoring out f of s from the two terms. Do you see what I'm talking about? Moving it over to the left, so it's plus 1 over s minus 1, and that's going to equal 6 over s cubed minus 1 over s plus 1. I'll just combine this to make it one term, s over s minus 1. Multiply by the reciprocal, so now we have 6 times the quantity s minus 1 over s to the 4 minus s minus 1 over s times s plus 1.
Can you just leave it?
Well, because we're looking for f of t, yeah. So I'll save us the time, but we won't do the partial fraction decomposition. I'll just tell you what it is. We can separate this as 6s over s to the 4. In other words, 6 over s to the third minus 6 over s to the 4. So I'm distributing the 6 and splitting up the fraction into two separate ones here. And then I'll do the same here. So this will be plus 1 over s. So the negative and the negative 1 give me a 1 over s plus 1 minus s over s plus 1. And then if you do the partial fraction decomposition here, which I won't do. Oh, we can cancel the s's. That works. So we have 1 over s plus 1 there. If we do partial fractions to get this guy over here, (6 over s cubed minus 6 over s to the 4), and what is that? Oh, see, I didn't do it that way before, but I guess I have to do it. Shoot. Okay, just for the sake of finishing in time, let's pretend I didn't do that.
Isn't A?
And I kept it as minus s minus 1 over s plus 1, and I did the decomposition for this instead of splitting it up. When you do the decomposition for that, you get negative 1 over s and then 2 over s plus 1. Once you have the decomposition, then you can find f of t. You just do the inverse, you get 3t squared minus t cubed plus 1 minus 2e to the minus t.